Hello, everyone. So see you again. So this class is a math call. Okay, so we continue our lesson from last class. Last period is we learned exponents, but now this another kind of exponents, but it's in the scientific notation pattern. When we're gonna use this one? When we're gonna use this one? When we made the number is very large or very small numbers. Okay, for example, can see this exponents provide, okay, exponents provide efficient way of writing and computing with very large or very small numbers. For example, see this, if we have 359 billion gallons of water on Earth, so you can see this is a very large number, correct? How many zero going to be? 18 zeros. See this one. So in this number is, you see this one, 359 billion gallons of water. So if you're going to like this one, how many digits? 18 zero, including 359, going to be 21 digits, right? So it's a really large. So if you like this one is, if you have more number, maybe in one line, this one may not enough, correct? So in this case, we have the mathematicians from France, right, named Nicholas. So he just have the idea how to make it short and clear to represent this number, right, without writing so many digits. So he have this definition. So we can see the definition of scientific notations is right here. This one, okay, from here. So we have to write this one mean C represent the real numbers. Okay, let me line the box first. C here, C represents real number. Okay, belong to real numbers. You still remember real numbers mean the can be rational, irrational, right? But in this case, it's can lay down in the decimal point. Okay, just say C restrictions right here. C, this one. C must be between this number. That means we learn how to read ordering numbers already, right? C is what? Greater than 10 and greater than or equal to 1. So this one, if we draw a number line, if I draw here, okay, for example, 0 here, -1 here, and 1 here. And for example, 10 right here. Okay, so this one on the top, and this one must be included. Why? Because you see they have equal sign here, right? So number 1 here have to be included. So we like the back dot. Okay, the darker color here. And then because 10 no equal sign, you see this one 10 no equal sign on the bottom, right? So this one have to be open, and then you draw one line. So this one represent C less than 10 and C greater than or equal to 1. Okay, this we learned from last period, last lesson. And one more thing is N. N must be integers number here, N. Okay, so remember integers, correct? Integer numbers have three kinds, right? 0 and the right hand side, 1, 2, and 3, and so on until past infinity. And to the left is what? -1, -2, and so on until negative infinity. Okay, then this one, another one is for base 10 always. When you do scientific notation, will depend on, we based on base 10 only, base 10s. Okay, so this is really important for the definition of scientific notation. You must lie in this one, have to keep in mind the definitions. Okay, so in this case, the example, come back to this number 359 billion gallons of water on Earth. So how we gonna make this in scientific notations? See this one. This one, if I load it down as I like down, say dot here, okay, decimal point represent. So I like zero at the back, right? So it's still the same value, correct? So in this case, how to make it? So we have to make it like a 3.59, right? So in this case, how we do? We have to move decimal point to the front, correct? Until we got 3.59, right? So from this one, from the dot here, from the dot, decimal point here. Sorry, I want to use skin color. This one, right? From the dot here, decimal point. I move up until I have 3.59. So we count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Go on. 16, 17, 18, 19, 20. So I'm going to stop it right here because I need 3.59. Okay. So I will have the dot here. I need 3.59. So this one, when I write in the scientific notation, going to be 3.59 times 10, base 10 here, times 10. Power, how many we count? 20, correct? So we'll index going to be 20. Okay, so because we count to the font, right? Count to the font, so the index 20 is a plus sign. Just keep in mind, count to the font. When you move the decimal point, move count to the font, then the sign should be plus. But mathematics, if sign plus, we don't need to write down. So elect the plus sign. Oh. So this one, okay. So gonna be 10 power 20. So we eliminate the plus sign. Okay. Now come back to this a large, really large number. Okay. Now come back to if this really small number, like this one electron is we have like a 0.000000000 here. The whole thing here, how many zero? We have 28 decimal places. Can say this from here, from the dot, okay, from the decimal dot here, from here the dot here, okay. How many zero we have? Include 9, okay, we have 28 digits, or can say 28 decimal places. Okay, in this case, again, if you like this is very long digits, right? Total 28 digits. So we want to write in the scientific notations. Okay, so how we gonna do? Then we have to try to get until we have 9.0, correct? Because 9 still within this definition, correct? In these definitions, this one. Okay, so in this definition, correct? So we have to try to get 9.0. So from this case, from the decimal point again, from the decimal point here, okay? So we can count, just move like this, 1, 2, 3, 4, 5, you keep count until you got 9 dot here, okay? So total, you're gonna have 9.0. So after this one, you have 9.0 times base 10, don't forget, power 28, because we count 28 digits, okay? But then because this one we count backwards, then you must have negative in the front. Okay, that's the way how to make it fast to count and get the scientific notation pattern. Okay, well, write each number in scientific notation. So right now they give us a decimal place, right? A decimal notation convert to scientific notation. The question A have 0.0000782. So in this case, a small number, right? So we have to try to convert to until we get the 7.82. Don't forget the definition. Okay, definition we must convert until we get plus minus c time 10, right? Power n. N must be belong to integers numbers. And c have to be less than 10 and greater than or equal to 1. Okay, so now this one we have to convert this one to be 7.82. Okay, this one should drop in this one, correct? Should drop in this condition. So now how to do it? From this one, you see the decimal point here, always start from the decimal point. So right now you have to move backwards, correct? So from dot here, 0, you move become 1, 2, 3, 4, 5. So I stop right here. I will stop it right here. So 7.82. So we count 5, right? So this one gonna be 10, become 7.82 times 10 power 5, correct? Power 5. But this one we count backwards. So don't forget we must have negative index, negative 5. So that's all, that's the answer. Now see next one, question B. B, this really large number, correct? Right? So 9 digits. So in this case, if I like the decimal point at the back and then maybe I like 0 here. It's okay, correct? 1, 0, 2, 0, still the same, right? But I want to like the dot here so I can start it. So from the decimal point here, right? This one. So I start count to the font. 1, 2, 3, 4, 5, 6, 7, and 8. So I stop right there because I need 8.36 because 8.36 drop in this condition, right? So I drop right there. So my the decimal point gonna be here 8.361. Okay, 8.361. So this one should be 1 here also. So in this case, what we have gonna be 8.361 times base 10. Don't forget the same thing, base 10, right? And what power? We count how many? 8, right? So you power 8. But this one we count to the font, right? So this one become plus sign. But again, plus sign, you don't need to write it down, right? So you just eliminate the plus sign out. Okay, and that's all. That's the answer. Same thing, right? See that. Okay, now come to next example. Just convert opposite. The next example is just opposite what we're doing here. Okay, so you see before is decimal point, decimal notation convert to scientific notation. Now decimal point give you scientific notation. Now question A here. This patterns are scientific notation, right? Right now we have to convert to decimal notations. So how to do like a question A here, right? We have negative 9.36 times 10 power negative 6. This one you can write it down become negative 9.36 times, right? You don't forget this one, right? This one, you do the exponent, remember the formula is what? We convert negative, right? So become 1, bring it down, become 10 power 6, correct? So that means you have what? Negative 9.36 divided by how many? 10 power 6, that means you have 60, right? Okay, so you can leave that way or you like 0 at the bottom, it's okay. Okay, that's the way how to do. Okay, so and then you use calculator. But in this case, otherwise you can do by, see from the previous example here, when you have index negative 6, right, there's this one, right, it's similar to this question, correct? So before we count backwards, and then you have with the negative power, right? But now because this convert from scientific to this pattern, before you count backward, right now you just count to the font, that's it. Okay, so you count to the front. So how we start? From again decimal point again from here. Okay, so from this one decimal point, you count it like this. I write down here 3, 6 like this, right? From this one you count to the font, right? Just do opposite from this one, right? Remember? So start from the decimal point here. So you count how many? 6, right? Try to get 6 digits, and the font have to be 0, 0, right? So then you count 1. Negative that we can leave this one first. Don't count elective, okay? I mean negative. So from here you count this one. From the decimal point you count 1, 2, 3, 4, 5, 6. Okay, when you have 6 here, you just lay the dot here. And this one, you like this one becomes 0, 0, 0, 0, 0. And when you have dot in front, can you another 0 up to you. So then you got this one. So final answer after you count from this one, right? This one, don't forget the question have negative, so you have to line negative in the font. Okay, so that means we have how many 0? 1, 2, 3, 4, 5, and then 9, right? But one after you move decimal already, decimal point, final this one have to be what? Negative 0 point 0 point, how many 0? 1, 2, 3, 4. So gonna be 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, and then 9, 3, 6. So actually this one have to times 10 power 6. Okay, but this only counting, okay, but from here have to be from here equal to this final, not this one equal. This one I better use like a arrow. Okay, use the arrow down here. This one not equal, okay, but I just show you how to count it. So actually have to be from this line, eh? Equal to this one, equal to this one. So that's the answer. But this one I show you how to count it down. Okay, now come to question B. If we have this one, 1.345 times 10, 10 power 2, then this is scientific, convert to decimal. So you see this index power, index positive is similar to this one, right? This is a power positive. Before we form this one, we count to the font. Now this one you have to convert decimal, then you count opposite, count to the back. So again, you start from the dot here, the decimal point here. Okay, decimal point here. So you count how many 2 digits because power 2 here. So you count 1, 2. So the decimal point gonna be here. Become 3, 4. So final this one after you move to the decimal notation gonna be 134.5. Okay. So just do opposite, that's all. Okay, I think we go next example. Can write like you have like this, right? 2, 4, 0, 0. How many 0 now? 6, 1, 2, 3. Okay, 1, 2, 3. This is a three number. Okay, so now this after this I can write 0 at the back, correct? Then I gonna move, right? Move to the font, count how many digits from the dot here, 0. So become 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I have the dot right here because I need 2.4. Don't forget definition here. Okay, this one, don't forget. So this one I gonna be equal to what? Equal to 2.4, and we count how many? We already count is a 9, right? Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So you times 10 power 9. Okay, this is a one bracket. Now you do this one. Okay, the second number here. Now this is 0.00045. This one you need become 4.5, correct? So you have to count backward. So we count now. 1, 2, 3, 4, 5, 6. Okay. So this one, the dot gonna be here. So we have 6, right? We times 6. So then this one gonna be 4.5 times 10 power 6. But then this one we count backward. Don't forget we must have negative bracket and divide it. Okay. Now see this number again. This is a very small number. We need what? 3.0, correct? This definition. Then count from decimal point again. We start this is a dot, right? 1, 2, 3, 4, 5. Okay. So then we have this one become 3.0 times 10 power 5. But don't forget we count backwards. Then this one can be minus. Next number. Okay. Next number you see what's gonna be 1,500. So you can write this one as a dot 00 here, right? And then you have to count until you got 1.5, correct? Because this definition. So then from dot you count 1, 2, 3. Okay. So I will stop my different dot decimal here become 1.5. So here you're gonna have 1.5 times 10, right? Don't forget that 10. We count how many? 3, right? So power 3. But this one we count to the font, right? So the plus become plus sign. That's all. Okay. After this one, how you do it? Simplify. You learn exponents in last lesson, correct? So you can write it down. Become from here. 2.4 times 4.5. You write it down first. 2.4 times 4.5. And then 10. This is the same base. Everyone see that? This is the same base. You can combine, right? So this one you can write down become 10 power 9 plus same base index plus because it's a time, right? So same base index plus. So you have 9 plus negative 6. Everyone get or not? Everyone get this? Then divided by this one, the same thing again. 3.0 times 1.5. So you have 3.0 times 1.5. And then this bracket, don't for this one, see that? See this one, base 10, same base. So you have same base index plus because this is a time multiplication. So you have 10, get the index negative 5 plus 3, right? 3 is a plus, so you have this one. Now we simplify. So 2.5, right? 2.5 times, we simplify the index first, times 4.5. And then this one become what? 10, right? 10, 9 plus, this one plus time minus come up become minus, correct? So you have the index here, you're gonna have 10 power, take it out, negative, so 10 power 3. So you have 10 power 3 here. Over 3 times 1.5, we have what? We have 4.5, correct? 4.5. This one you can use calculator if you want, okay? Use calculator. So then this one base 10, the index negative 5 plus 3 become 10 power negative 2. After this, you can see 4.5 can cut, right? Okay. But then this one, what we can do, so 2.5, 2.4 die down first, okay? And then this one, you see base 10, right? So you can, which one should move? Index negative, right? We move to the top, become plus, correct? So we have 10 power 3 like down. Move 2 up because negative, I want to make a positive every time, don't forget. So negative 2, you move up, become plus 2. Okay, so then we have 2.4 times, I can write this way now because it's a time, right? Times 10 power 5. Okay, so you can leave this one, this answer like this. It's okay, and then you can use calculator, or doesn't matter because 10 power 5, you know, should be what? 2.4 times how many 5? 5 zeros, right? So you have like this one, 5 zero, 1, 2, 3, 4, 5. So this have one digit, so one zero should gone, so become 2, 4, and how many zero left? 1, 2, 3, 4. So 1, 2, 3, 4. Now you left this a final answer. Okay, so same thing, correct, everyone? Okay, then I think I will leave it right here, and then you can practice question. You check in GC. Need any help, just contact me, okay? I think that's all. Bye-bye. See you next class. Bye.